Okay, so we'll be continuing with the pig that we discussed yesterday. So let's take one more example on pig, which is let's say a very simple data. I have a user and he has purchased some book. So that's a book name actually. Hadoop, Pig, Hive, Spark, ML, like that. So one user has purchased many books. All right. So here you have a user and the number of books that he has purchased. So I just want to know the total number of books every user has purchased. So that means count of books for each user, right? So how do we solve this problem? We will basically actually first we'll go to the run shell and then we are going to add this. We are going to
perform the steps where we will understand first that we will load that file into the table, and then we will of course do some operations using group by clause to count the total number of books read by every user. So here let's say I want to read the book. I want to first load the data into the Hdfs. So I have to basically copy this path
How about now? Is it better? Okay. So as I said, you have to load the books into the table. Of course, there is a comma as a separator, so we need to basically use this using pig storage as a name of the user and of course the book name. So we were able to successfully load the books. Now tell me one thing, which is the command I should use to check or debug whether this step works fine or not? How do I do that? Yes, very good, Shantanu and Nikhil. It is an illustrate command. So I just need to say illustrate books. And it would actually show us the way it has loaded the data into this table, right? Yes, so it has put the data in the correct columns, right? So this is fine. We wanted in this. Now you have loaded the data in table. Now what you need to do? You need to basically do group by operation, right, for users. So basically, let's say I'll generate books group as one table, and I'll just say group books by name. Okay. Now if I do illustrate books group, what would happen? Excuse me. It has generated like this. Okay. Every user's and the corresponding books that they have bought, it has actually got it that way. Just 1 second. Now here I'll show you one more interesting command. Now for each books, I need to generate a count. So I'll just say books count for each of the records in books group, right? I'll say generate group. Group is a function which I want to call. I have to count total number of books, right? So count the books as book count. Now if I do illustrate on book count, what would happen? So as you can see, it would actually now show us the total count, right? Here see, user 2 has 2 books. We have grouped it in this order. And then once we group it in this order, we are saying now get the count the total book or total number of books per user. So it has counted this way. User 2 has 2 number of books, right? And I am taking that column alias as book count. So as you can see from this command, this book count is just an alias which is of the column, right? So now it is referred as book count. So that this step is the final step that we wanted to have. Now what you can do is you can actually also order this. For example, you can say ordered books, or let's say sorted books based on the count. So you just say order books count by books count. This is the column. Based on that, I want to sort it. Oh, it's book count, not books count. This is the column. Now if I do dump on sorted books, you will get a final output which has all the books list in the sorted order. I mean, all the users count will users who have purchased total number of books, and based on the total number of books, that user will be listed. As you can see, it's listed in the ascending order. The user who has purchased least number of books is first, then second user, and then so on and so forth, right? So this is how we can solve this problem. Okay, are we clear on this? Anybody has any questions on this problem statement that we executed? Yeah, I'll show you all the steps again. This was my first step to load the data from the books file into this table with 2 columns. Right? And these steps everyone knows how to do it. After that, what I have done is I have done group by. I have just saying groups books table by name. So all the groups will be created for every user, right? That table name I am giving it as books group. Now based on that, I am doing for each. For each books group, For every record in books group, generate group count of books as count books count. So basically, after generate whatever you write, it's called function, inbuilt function. So group is a function, okay, which will be applied for every record in books group table, and then you are saying count of total books. So you want to basically get the sum of total books as books count. I'm just aliasing it as one column name. And finally, I'm also ordering that by basically, right? Order the books count by book count, that's a column. And then finally, I've just said dump, right? So these are the 5 statements that I have written here. Is that clear, everyone? So Mary, are you clear with this command? Let me know if anyone has any doubts on this. So this is one example through which you can process or analyze the data, and this is the steps of the big script that you need to write. Now the same thing, if you want to achieve using MapReduce, you have to write so many lines of code. Here you can finish it in just 4 or 5 lines. I'll also show you how, let's say, we'll take an example of a word count and we'll understand how a word count problem can be executed using pig script. Okay, so that way we will get a clarity about what all statements we need to write. So first I have to quit from the local mode because I want to show you now one demo on connecting to distributed mode. So we'll be connecting to the distributed mode and then we will execute one program. Okay. Now here I have to first check whether my file is available in Hdfs or not. So I need to go and check that. The file is not there, so I need to copy it. So what I'll be doing is I have a words file as you can see here. Okay. It is basically just unstructured data, plain text, where some words are separated by space. We want to count the occurrences of every word here. So I'll first copy this file in Hdfs because we have logged into the map-read mode. So we definitely need to use this file by talking to the Hdfs, right? So we'll execute this. We'll first copy the input file into Hdfs and then we will write a pig script to process that. Alright, so let us start writing a pig script. Now let's say I have a file available in Hdfs, okay, which is basically having words as a file name. That file contains all the words which are separated by space. Now let us try to understand how do we write program to process this data and count the occurrences of every word, right? So now you guys tell me the steps. You tell me what would be the first step and I'll write it accordingly. What should we do? Let's say my file is available in Hdfs. What should we do first? Yes, load into the bag. That's correct. So I will create, let's say, a words file, a table, right? Or I'll just say lines. Lines would be more accurate because it has all the lines. I'll just say load. I'll give a path which is an Hdfs path, right? Use each. Now see, whenever you have unstructured data which you want to process using pig, right? Remember, you have to still load that file into the pig table first. But since it's unstructured data, you can't separate out columns. So you can take only one column. I'll be taking only one column, right? As you can see, I'm just taking a table whose name is lines and it has only one column called line. Okay. If you do illustrate, it will show you the way. Oops, sorry. It will show you the way it has loaded the data into the table, right? So this is one line that it has loaded into this table, lines, where the column name is line. All right. Now you tell me what should be the next step. If I want to process this problem, what should I do to achieve the next step? Think logically, like what are the steps that we should achieve now? This is the file. This is the file, Shantanu. Yes, Nikhil, that's perfectly valid. Each line or each record we need to split and get the words, right? A very normal logical thinking, correct? We have this entire record, we have loaded it into a column. Now every record I want to convert it into words. I want to separate it out into the space. So what you should do? You can just say words bag is equals to for each lines, right? Generate, and then there is a function which separates out the words. Tokenize line. That's it. Basically, for every record, you want to tokenize that into words. So tokenize is a method by passing the column inside a tokenize. It will separate out all the words which are separated by space. Okay. Sorry, this should be capital. Okay. So now if I do illustrate on words tag, you can see that it would now have all the words separated, right? See, earlier it was having one entire record, now every word is separated like this. Correct? So that's good. We have got the word separated for every record. Now you tell me what should be the next step. Logically, what should be our next approach? Make that to tuple. What does that mean, Nikhil? Yes, Raghu, that's right. So you need to basically group the words, right? You don't need to make the columns, right? Why do you need to make a column for every word? That doesn't make any sense, right? We just need to find out how many words are similar. Just group all oranges, group all mangoes together. That is what we need to do, right? Because overall aim is to count it. So here what we will be doing is, first, by the way, as you can see in the last illustrate command, my words are listed as one list only. Okay. So whenever you want to group any data, whenever you want to use a group function, right, it has to be first put in a column order or in a array kind of structure. Then you can apply for group function on top of that. Right now it is not that in that order. It is just a separate comma separated list. So I need to first convert it into array kind of thing. So how do I do it? So I'll just say words is equals to for each words bag generate flatten. I want to flatten this column. Since it's a huge name of the column and we don't know that internally what is the name given, we will just say $0. $0 represent first column. Okay. And now that column I can give any good column name. Let's say as word. Okay. What does flatten do? Flatten will basically take this list of words. It will be something like this. You can just see it here. It will take these words which are comma separated and convert it into this kind of array. Orange, apple, banana, mango. Right? So I wanted them to be in this structure first, and then only I can do group by operation. Right? So this is what flatten does. And hence, once I have this flatten function, I can actually also name that whatever. See, if you don't give a name of the column, these kind of operations will give such kind of names which I'm highlighting. It will be like very big name. So instead of that, I just want to give an alias of the column name as this so that I can refer that column later if I want. Okay. So now if you do illustrate on words, it would basically show you all the words which are created as one array. Right? Cool. So you got an array. Now you need to basically do what operation? That's what I think Raghu has said, which is you need to group all the words, right? Steps will be you want to basically group words, you want to create a word group by grouping words by word. Simple. So what happens in that case if I do illustrate? I will get these kind of records where all mangoes are grouped, all oranges, bananas, apples are grouped, right? So this will give me a very good representation of the data, and we can easily understand what has happened at every step, right? So it will start from first step. It will say this is the line I have taken, second step I have done this way, third step I have done this way, and fourth step I have grouped it in this order, right? So this is fine. We exactly are doing what the way we expect this, right, to do. So basically we are doing fine here. Now we need to just count this occurrences, right? Correct? So I'll just say, let's say I want to create a words count. I'll just say for each words group, again I want to apply a count function, group function on this counts. So where is this is something wrong here? Oh, okay. Thanks for pointing it out, Nikhil. Yeah, so now we are good. We got the count of total words. Right, so as you can see, every word is counted for the occurrences, right? And now you can also sort them. If you want, you can sort them based on the order. You can just say words order is equals to order now I'm ordering it based on the count, right? So I have basically calculated the total count of every word, right? And also I'm doing one more extra step, which is I want to order every word in the list based on the count, right? Whoever's count is first, more, they should be present first. I think I have ordered it in a natural order. Let me just order it in a descending order. Now if I do illustrate, it will basically do it in a descending order. So whoever words count is more, that word will be presented first in that list, right? So here, as you can see, yeah, I got all the words and their count based on that they have ordered it. It's fine. I mean, it will definitely work fine. Right, so this is how I do it now. But the important difference that you want to understand between MapReduce and this is let me just first write all the statements here just to show you the what has happened. Okay, this is what has happened. So these are the 6 steps that I have written to generate a MapReduce program. But the important point to notice is in the actual MapReduce program that we have written using Java, we could complete it only these many steps, where we could generate the count of every word, where the words are sorted based on their names, right? If I had to sort the words based on the count, based on the values, right? Then I had to implement a technique in MapReduce called secondary sorting, which is like, very advanced technique, and that requires a lot of coding. You need to write your own comparator class, pass that as a value parameter, and lot of stuff needs to be done so that you will be able to sort all the keys based on their values, right? So this is what we have done in the just one step here in pig. We don't really need to do any further complex operation. We just sorted them by count, which is a value column. Like so, now we presented all the words in the order based on the count, so that whichever words count is more, that word is presented first in the list. Right. So as you can see, pig simplifies the effort of coding and development. In just 7 lines of code, I could finish the entire MapReduce program, which if you have to write it in Java, you would have spent at least, probably 30-40 lines. So that's the kind of effort that we are talking about, which can be saved using pig development. Okay. So are we clear on this? Anybody has any question on these statements that I have written? So Raghu, MR code is not persisted, it will be deleted immediately after the pig completes. So they don't really keep it inside. So that's why actually, it's because it's a job completion stage where it cleanups all the intermediate stage data, which is why MR code will also be deleted. That's what I answered, Raj. Raghu has asked the same question. We cannot see the MapReduce code because it is internally, once you execute this program, right, it will be deleted automatically. It doesn't keep that. As a final stage, which is job completion, it deletes all intermediate output of mapper as well as the entire MapReduce job. I mean, a MapReduce program. Okay. So I think that answers Mary's question also. Is that clear, guys? All of you had the same question. By the way, one important point to notice is even if I have written these 6 steps, right, nothing has been generated. No MapReduce program has been generated here. Okay. Yes, Vishal. I'll be doing that. I am just going to do that. But I just wanted to show you that no MapReduce has been generated here. Now see, we have executed it in a MapRead mode, right? So it is going to execute the entire MapReduce program in a distributed way to process data in Hdfs. It will take some time. So we will just do dump of words order. If I do this, now it will start generating it as a MapReduce and then executing it as a MapReduce in a distributed mode to process data in Hdfs. Okay. So let's see how it works. See, here it is also creating a jar file. After creating a MapReduce, it is creating a jar file also. So everything is internally being created by the pig. We don't need to do anything. And by the way, Raghu, yes, we can run these steps as one batch script. I'll show you that as well. Okay. As you can see, it is executing a little slower. Just 60% completed. As you can see here, it is taking some more time to execute it, right? Now the reason being is, of course, there is some process which is running in my machine, and also it's a single node cluster, so you don't really get the actual power of distribution. But even compared to MapReduce, which we have executed on the same machine, it is slower. So that validates that pig scripts are in fact slower than MapReduce, native MapReduce, because here it first, do a lot of internal validation processing on generating the MapReduce and then giving you the output. But in case of MapReduce, it's directly executing it, right? So there is definitely minor differences in terms of performance. pig is little slower than native MapReduce. So as you can see, we got the output created. Okay, we have actually got like all the words printed in that order in a basically a descending order, right? Based on the count of the total occurrences of that word. So is this clear with everyone? Any questions on this? Okay, so let's no, Mary, you need to understand, right? In Java, we have actually written words dot split, the value dot split, right? The MapReduce program. Remember? I'll show you that code for your reference. See, this was a MapReduce program that we have written. We used to split every value based on the space, and we get the words, right? Got it? So it directly gives us the array of words. Okay. Now, let me come out of this grunt shell. We have seen different functions, different types of pig scripts actually. Now we will also execute, I think Raghu had a question how to execute it in a batch mode. So let us try to execute that one. So the credit score example yesterday we did, right, where we have a customer in US, US customer and India customer file with their name, city and score. I want to basically find out total number of good and bad customer. So here what I'm doing, just load two files, then union them, then split them based on the into good customer is score greater than 5, bad customer otherwise, right? If score less than or equal to 5. So this is what I'm doing, and then finally I'm ordering good customer by their score descending order, and this is what I'm dumping, right? So this is what we have executed yesterday, right? When we executed our first pig script. So I don't think you need to understand all these steps again, but I am going to put all these steps as one file. Okay, so it is called batch mode. So you need to put everything in a file. The extension of that file will be .pig. All right. So I'll just say pig -x local the file name. Why local? Because if you see here, it is going to read the data from the path which is local file system. I think I need to change here a little bit path. Okay. This is what I want to do. So anybody has any question on these steps that I have written? Can you hear me, Raj? Okay. So I was just waiting if anybody has any question. All right. So let me execute it as a batch script. Pig-x local credit score.pig. If I execute it as a batch script, what it does, it will execute all the statements in that script and then generates the result. So here if you see, I have not even gone to the grunt shell. Directly I have executed this script without logging into grunt shell, right? This is how you can execute everything as one batch script. Okay. As you can see, all the customers who have credit score more than 5 are printed in this order, in the descending order based on their score from both US and India, right? So this is how we can execute any script as a batch script. Is that clear with everyone? Raghu, are you clear with your question? You wanted to understand this, right? Okay. So now we will cover one more topic in PIG, which is how to write UDF function, user-defined functions, right? Now, what is a UDF function? What is a user-defined function? So the user-defined functions. Yes, Raghu. So basically, what happens is if your data is very huge, anyway, it is internally going to create a map reduce. So the output of that, when you store it, right? When you say store that command, it will basically create multiple part.r files in case if it creates more number of reducer. So it will do it automatically. We don't need to worry about that. Okay. So now let's talk about UDF. What is UDF? So UDF is a user-defined function. What is the use of it? So the use of UDF is basically, let's say if you are writing or solving some problem and you want to write some interesting logic, but then that the current PIG scripts are not enough to handle that, or it doesn't have all the support to basically execute that logic.
and you want still better control with Java kind of programming language, so you can actually write that logic in a Java, and then you can call that logic from the pig. That is called UDF function. Another important advantage is basically, let's say you want to have some common functionalities. A very simple common utility is like, maybe let's say you want to find out you want to convert any string into uppercase. Very simple utility, but very useful utility. Now, instead of writing this code again and again for every big script, you can actually write a Java kind of function for that and call it whenever you need it in every big script. That's how you can make it more generic. That is also one more advantage of having a UDF, right? So that is why UDFs are done, and many people use UDF because they are comfortable with Java and they want to write some important logic using Java's features, and then they call it in pig. So that is also possible, right? So I'll show you one example of UDF, and we'll understand how do we solve the UDF problems using pig scripts. So just one second. Let us first write one UDF function, UDF class basically. Okay. So I'll be showing you this. Just one second. Am I audible, everyone? Hello. Am I audible? Am I audible, everyone? Hello, everyone. Am I audible? Am I audible, everyone?
Hello everyone, am I audible? Okay, let me just talk to Simpleton team. Looks like I have lost my presenter rights, so it just, yes, I got it back. I'll be showing you the screen now. Okay, so let us start with a pig UDF, right? So as I said, we need to write a pig UDF. We need to basically generate a uppercase UDF. So I'll be doing this way. I'll just say new class. We'll write upper UDF. Okay. And this class, what we write, it has to extend from eval func. Eval func is a function of pig which expects a string. See, our job is to basically convert any data into uppercase. So this eval function is provided by pig jars, pig libraries. You need to import a pig library in your build path. Okay, let me just do that. So now it has imported that eval function, right? Now here you need to override one method which is basically called execute. All right. See, it's like if you extend eval function, you have to override execute method. So whenever you call this code in pig, this method logic will be executed automatically by pig, right? So this is it accepts one tuple as one row. Now you can just write this if tuple is equals to null or tuple dot length equals to 0, then return null. Okay. Otherwise, let's say I want to convert, for example, this credit score example that we have taken, where we have name, city, and score, credit score of the user. I just want to convert all the city of the users to the uppercase. So I'll just say tuple dot get. It's a second column, right? So it's actually 0 base index. So get one will give me the city. So I'll just say string city. You can just convert it into string, and then I'll return that. Return city dot to uppercase. I'm returning the city into the uppercase. Of course, there is a
the other columns I want to return it as it is, right? So I'll just say tuple dot get of okay. This is what I'm doing. Basically, I'll get entire tuple, right, which will have three columns: a city, name, city, and the credit score. So I just want to convert city into uppercase. So I'll just extract second column value city, and then what I'll do, city dot to uppercase, and then the other columns as it is, I'm prefixing it, right? I'm just adding it to the same output. Then I'll make one more string, and that string I'm returning, right? So for every record, I'll take the city value, convert it into uppercase, and then remaining two columns, I'll keep it as it is, and that string I'm returning as a result. So that is what we are going to do in this operation, right? We'll convert one particular column into uppercase using this. So is everyone clear with this? How to write a UDF function or to convert anything into uppercase? Any questions, doubts, concerns you have on this? By the way, I have to create a jar to execute it. So I'll be creating a jar file. And I'll be done with that. So I have created a jar file. So I'll just quickly repeat for everyone's benefit. What I have done, I have created one class which has to extend from eval func, which is a pig class, right? And you have to override execute method, which expects tuple as an argument. You are just checking if it is null, return null. Otherwise, take the second column of this tuple, which is, let's say, city. How do you know whether city is the second column? Because I'm going to pass the data in that order only, right? Because I want to use this UDF for that credit score table, and I want to convert city data into uppercase. So I'll just take that city column, convert it into uppercase, and prefix it with other two columns and return that result. That's it. That is what I'm doing for every record in this table, right? For every tuple, and that is how this UDF can be applied there. So is it clear? And to call it in pig UDF, sorry, pig scripts, I need to make it as a jar, and then I can use it. I'll show you how to do that in pig scripts. Okay. So we have created a jar. Now what we'll do is we'll come out of this, and basically we'll create a new script. Let's say I want to write a script called udf.pig. Okay. Here what I'll do is, let's say I want to take a USA customer data. I'll just take one file. Okay. I want to load the data from Okay, so I'm loading everything as one table in USA table, and then I'll just use this to split, right? So I'll just say split USA into good customer if score greater than 5, bad customer if score is not if, otherwise. You can just put otherwise. That's it. And then you'll just say dump good customer. That's it. So instead of reading from two files, making them union, I'm just creating a 3 steps, right? Which will do this problem. Now, where can I use this? Where can I use the the uppercase, basically uppercase stuff? So I'll show you that. Where can I use this? In fact, instead of splitting also, I can do something like this. Since I just want an uppercase, right? I'll just say for each USA record, I'll just say generate, and I'll call a to upper function, and I'll pass these 3 column data: name, city, score as one tuple. Okay, and let's say this will give me the result of USA city upper data, and this is what I want to dump, right? USA city upper. All right. Now you need to add a jar here, so you'll just say register the jar name, the actual jar which you have created under home Cloudera. I have pig UDF dot jar, which you need to register. Then you will say define a function, right? Define is to define a function. See, to upper is what I'm using as a function name, so I'll just define to upper, right? And then you need to say as which class. So you see here in my jar, I have in Eclipse, I have created upper UDF as a class, right? So I need to copy the qualified name and I'll paste it here. That's it. So basically what I'm doing is I'll just say register this jar, then define this function, create an alias of the function which internally refers to the code of evaluate method in this particular class. Okay, it will execute the method called execute under this class upper UDF, and then finally once you have this upper UDF, it will basically do what? Yeah, it will basically, you load the data from one file into this table, and then simple, you are reading each record from that table, and then you want to convert it into uppercase, so you are just calling that function here, right? And then you just pass this entire tuple as a record, which will convert it into uppercase, and then just dumping that data. That is what you have done. Yes, Vishal. All the functions that you want to call, all the code in Java that you want to call, you need to have one alias, right, which is a function name, to which you can refer this code. So that is why you need to always define this. Okay. So by the way, is everyone clear? Anybody has any questions on this pig? How do you call a UDF function in pig scripts? No, Raj, you have created a to-upper function name, right? So that function name you need to use it in every script. Internally, when this function is called, right, pig we should know which class I have to execute. So that is why you have defined this mapping. So it will go to this class under this jar and execute the code of that class when you are using this particular function. Okay. Yes. Any further questions? Shiva, pig is not available in GUI, but yes, I mean that is a hue component available, which I'll show you later. Through that you can execute pig commands. For example, let me show you right away. There is a, as you can see, if you open browser, there is something called hue. It is called Hadoop UI. Okay, so if you open that, it will actually basically ask for username password, which is Cloudera. And once you log into that Hue component, in that you will have some editors available, GUI editors for pig script. So you can write a pig script using UI itself. Even for that matter, Hive also you can write it using UI. As you can see here, there is a pig. There is a pig editor available, query editor, and here you would basically see that. So as they have given one example, right, you can actually start writing all your code here itself and then execute it. So it's basically executing pig script through UI mode. Okay. So is that clear? Okay. So let me now execute this particular script which we have executed. I directly call pig script. So how do I use it? Pig-x local call UDF, right? It should print the uppercase city names along with the other two columns. Okay, it throws an error. It says input path does not exist. Home Cloudera Hadoop training pig demo. Okay. So there is some problem. We need to correct that.
I have to put a slash here. Under root only I have to add it, right? So I should be having a slash. Now it will work. Let me just save it and re-execute it. So as you can see, it has printed the username, the city, and the credit score. But all the three values it has printed together. Only thing is the city is printed in the uppercase, right? So is everyone clear? We could print the city in uppercase by applying the UDF functions. Any questions on this? So by the way, did you all understand this part? Okay, I'll show you one more example on this, which is, it is also possible that you can call pig scripts in Java itself. Okay, the reverse way. We have called Java in pig. Now you can call pig commands in Java. So good news for the the developers of Java. So I have actually copied a class here, okay, which has that code available. By the way, I'll share all this code with you, so you don't need to worry. There is something called execute pig, a Java program which I have written. Okay. See, what does it do? Just check here. It has a main method. What does it do? It just calls some APIs of the pig server. And what it does, it just say run query. Run query is a method which takes pig server and an input file. Input file is this. So in my case, let's say under home user, home Cloudera. I'll have Hadoop training slash pig demo slash let's say customer US file, right? And I want to load it as name, care, array, city, score isn't here. Okay, you call it as custom USA file. Now I want to order them by the name in the descending order. Okay, that's the USA order. That's the data I want to generate, and then finally I want to store that into one output under home Cloudera sorted names. Okay, this is what I want to do. So basically what I'm doing, I'll quickly explain. Just the same input file you are using, I'm loading that, and then this is how you can execute that pig queries directly through Java pig server.register query. You are registering these two queries and order the USA by name in descending order. After that, I want to store this output. So you'll just call store command to store the output from this table into the actual the file system folders, right? And I'm actually using a local mode to execute this command. So my input is in local file system, output will also be in local file system. So through this Java program only, I'm going to execute everything as pig scripts. So is it clear with everyone? Any doubts on this, how to execute a pig commands through Java itself? This is one more way where sometimes you may feel a need of executing pig commands directly through Java, so you can do it this way. Right? You can just say right click and just say execute. No, Vishal. So here instead of local, you can pass MapRed. That means it will be an Hdfs automatically. Okay. MapRed is a mode. Just give me 1 minute. Looks like it is looking for an external jar, which I need to, download it. And it should work probably.
Yeah, I'm just downloading that extra jar, okay? Just give me 1 minute. I've just imported that jar from the external systems. Let us check if it works fine this time. Basically, see, runtime, it actually needs a lot of more dependency than the normal jars. That's the reason why it is actually, it was giving those errors. So it says successful execution. It is completed. So let us go and check in the, if I do LSF and LRTH, I get sorted names. If you go to the sorted names, right, and if you do ls, you can see there is a part R0 file created. If you do vi part R0 file, you get all the names printed in that in the descending order, right? 5, 4, 3, 2, 1. Based on that, we have printed that. So is that clear, everyone? We can actually call a pig commands through Java itself. Any questions on this? Anybody? No, Nikhil, that is actually, it's just like, it is not a good approach. Why are you calling Java within Java? It's a Java, right? UDF is Java. So, I mean, ideally you can, right? It is possible, but then it is not a really good solution. You have Java, just write that method in the Java code itself and call it, no? Why do you want to have a UDF and then call it from Java, correct? So it's not advisable. Technically it is possible, but it will be very dirty code. Yeah, that is fine. That's possible. All right. Any further questions on pig? We have completed pig, by the way. So we'll be starting now Hive. All right. So what we can do now is we can take a break. We'll come back after the break and we'll start with Hive. All right. Okay, fine. So see you all after the break.
Can you hear me now? Hello? So let us talk about Hive. We'll start with Hive and we'll understand how Hive will help us solve some interesting problems. So basically Hive is for structured data analysis. It's a data warehouse component for Hadoop, right? Which stores big data, and of course it represents, it forms a layer where all the files, all the data that you can store in the form of files in Hdfs, you can view it in the form of table rows and columns, right? So Hive layers the table definition on top of the file stored in Hdfs so that end user can write SQL queries on top of that and start analyzing the data. Okay, so that is what Hive does overall. And we will now talk about internal architecture of Hive, and we'll do some hands-on as well with Hive. Hello. Hello everyone, can you hear me? Okay. Yeah, so I was just mentioning about the Hive and its motivations. As I said, right, the motivation behind Hive is the same. People who are not comfortable while writing MapReduce, they don't need to learn MapReduce. They can actually learn high-level scripting language like Hive, which just expects people to write analysis logic in SQL query, and internally it will be converted into Hive MapReduce programs. Hive engine will take care of converting SQL queries into MapReduce program and then process the data on the Hadoop cluster, right? So it provides a SQL-like language called Hive query language, and due to its SQL-like interface, Hive is popular choice for Hadoop analytics because most of the people would be aware of SQL, and hence it becomes easy for them to work on Hive, right? So that is why Hive is more popular. It provides massive scale out and fault tolerant capabilities using MapReduce, and it relies on MapReduce for execution and processing the data stored on Hdfs. Okay, so basically Hive is going to Hive engine is going to convert your SQL queries into MapReduce and then process the data stored on Hdfs and give you the result back. So these are the principles of Hive. Performance is better in Hive since Hive engine uses best inbuilt script to reduce the execution time while enabling high output. Of course, fault tolerance, reliability, extensibility, all these are key features because it uses MapReduce framework to process the data, and we have already understood in MapReduce, right, why it is fault tolerant, what kind of failures are handled. So because MapReduce itself is internally capable of handling all these failures, and hence it is an important choice for Hive as well. And because and that capability will be internally used by Hive to achieve that. We'll talk about an architecture of Hive system. One will understand how does each component fit here, how does it look together. So Hive architecture actually layers into three different buckets. Basically, if you want to understand the Hive architecture, it has three basic layers. It has access layer, it has a middle layer, which we also call it as the engine of Hive, and of course it has a backend, which is for our case Hadoop system, right? So mainly it has three layers, and the first layer is basically an access layer through which you actually submit Hive queries. So there are various ways you can submit Hive queries to the Hive engine. You have command line interface, you have web interface, thrift server. So Hive can be started, by the way, as a thrift server, and then you can use any UI to access Hive and submit your Hive queries through that UI, which will go and execute it on the machine where Hive is installed. Hive server is running, right? So you don't need to log into the machine where Hive is installed. You can access or execute a Hive query from outside any other machine, provided Hive is started as thrift server, so that you can access it using HTTP. The same example that we have seen on Pig, there is a component called Hue, H-U-E, right? That only I'll be showing you again for Hive as well, where you have Hive query editors and you can type all the Hive queries through UI. It will go and execute it on the Hadoop cluster and give you the result back on the UI, right? You can also choose which database to work with, which table to work with. So there are a lot of flexibility given in that UI. So that is about accessing or writing Hive queries through web interface. Then you have a command line interface. Just like in Pig, we have seen that we have to log into grunt shell. In the command line interface, we have to log into the Hive shell. Okay, and we will be writing a lot of queries of Hive using Hive shell, which I'll show you that going forward. And there are, of course, two major components, JDBC, ODBC layer. So basically, you can also write a Java program, and then from Java program, you can connect to Hive repository using JDBC, ODBC driver for Hive. There is a driver available for Hive. If you import that and if you use that API to connect to the Hive repository and get the data and process it using Java class itself. So that is also possible. So these are various ways you can submit Hive queries to the Hive engine. Okay. Now, when you submit Hive query to the Hive engine, it goes to the backend layer. All the queries will be submitted to the backend layer. In fact, a middle layer, and in the middle layer, you have a component called driver, which is the mastermind behind Hive. It is called Hive engine. The capability of Hive engine is to compile, optimize, and execute Hive queries. So once it receives the query, it will first compile the query for the validation errors. After that, it will actually execute the query plan and basically optimize that query plan for the better execution. After which it actually generates a MapReduce, which is again an optimized code, and then execute it on the Hadoop cluster, and the result will be returned to the client. Okay, so a lot of enhancement would happen during this process where you want to basically compile, optimize, and execute the query. But this is the guy who's intelligent enough to do that. We don't really need to worry about doing anything. We just apply SQL queries. Internally, driver component will take care of converting into MapReduce and execute it on the Hadoop cluster. Okay, but driver component, to do this job, it has to make use of this component called metastore. So driver component also parallelly reads metastore many times a day to basically make sure basically driver component will make use of the metastore to find out where the actual data is stored for this table, right? So there is a lot of mapping information stored in metastore. We'll talk about metastore after this slide, where we'll understand how does Hive store data internally. But this is an important component which is used by driver so that it can process data on Hive tables. And then once the driver generates a MapReduce, it submits it to the backend layer, which is a Hadoop infrastructure layer, which has MapReduce, Hdfs, all these things. So basically, it basically leverages the backend layer of Hadoop to execute MapReduce and process data on Hdfs and give the result back to the client.
So this is how overall architecture looks, overall architecture works, right, to process any Hive queries. Okay, and if you go to the subsequent slide, they have explained about different components functionality, driver, and all the other stuff. But the important point is Metastore, which we need to understand. So I'll explain it. Before I move forward, is everyone clear as of now? Any questions? Okay, so since no questions, we'll move forward, right? Now I'll explain you how Hive works internally and how does it make use of Metastore. Okay, this is very, very important to understand. It's not explained in PPT, but let's understand that part. So I have a Hive prompt, right? Hive shell. As I said, you can submit a Hive query using command line interface. So I'm logging to the Hive shell. From there, I'll be firing some queries which connects to the Metastore, and from there, it reads the data from Hdfs. So let us do that. So let's assume that in Hdfs, I will have some data available in under some of the directory called data. Under that, I will have some file available, employee underscore data dot txt. Right? This is the file which is, let's say, available in the Hdfs. Now this file will contain a lot of data about information about different columns, like what is the user ID and stuff like that. When your program is basically in the file, you will get user ID, name, salary, department, all these details will be there. So I want to use this file which contains employee details, and I want to load it into the table. Okay, so I want to create a Hive table. So how does it happen? In the Hive shell, you can just execute a create table syntax. You will just say create table employee. You will just say column 1, column 2, and so on and so forth. Right? So basically you have fired a query to create a table. Once you execute one query in Hive shell, what happens behind the scenes? So in the Metastore, which is a relational database system, Hive, by the way, uses a Metastore component, which is nothing but RDBMS to store all the mapping information. Okay, it will basically give us. It has also I think. Yeah, so let me repeat it. So when you create a table, what happens internally in Metastore, it will create one entry like employee table and schema definition. So what is the column? What is the type of this column? so and so forth, right? So all this information will be stored as part of the schema definition of this table. And this is called mapping information, which is stored in Metastore, which is a relational database. So Hive, when you install Hive, by default there will be one RDBMS configured for Hive, which is called Derby database. Okay, where it will store all the metadata. But you can choose to include any other database if you want. I mean, if you want to store the metadata, you can choose to include any other database other than Derby. So that is also possible. Okay. And then internally, once you create a table in Hdfs, remember one thing, whenever you create any table or load data into table, actual data will be created in the Hdfs only. So it will go to the Hdfs, and under this it will create a folder user. Inside this folder, already this folder will be created in Hdfs when you install Hive. User Hive warehouse. Under this directory, it will go and create a directory name employee, because that's the name of the table. It's an empty directory it is going to create. So by default, always when you create a table in Hive, it will go and create a corresponding directory in Hdfs. Okay, and it will put a mapping information that this table is mapped to this particular location in Hdfs. So the mapping information gets stored in Metastore. Okay. Now, by default, always it will put this table under user Hive warehouse directory, because this path is configured in Hive site.xml. But you can choose to change the value of this path, and you can ask Hive to write the data in some other location. That is possible just by changing the property in Hive site.xml file. Okay. Now we will talk about. So this is just one command we have executed about create table, and we understood what would have happened internally. Now what we need to do is, let's say I want to load data. See, I have this file empdata.txt. I want to load data from this file into the table. So this is one important feature I wanted to understand. I wanted you to understand, which is, see, Hive will basically store data in Hdfs in the form of files, right? Now we understood in Hdfs architecture that whenever you store data in Hdfs, it will be kind of warm, write once, read many times, right? You can't change the data within the Hive files once you create the file. So basically, because of this behavior, actually Hive is not a right choice to basically, it is not a right choice to update any data in the existing table, because internally it will use Hdfs to store data. So in that case, you may need to rewrite the entire file again, or you may need to delete and then restore the entire file again. So basically what I'm trying to highlight is, in Hive, there is no support of updated records, which means in Hive you can't have update queries. In Hive you can't have insert query also to append data. See, write once, read many times. So if I create table, and if I put, let's say, 10 records in that table, after which I cannot add 11th, 12th or 13th record in the same table, because it is write once, read many times. So once you load data in table, that's done. After that you can't append the data. You can't delete any particular record from that table. So these are the major challenges, and because of which Hive does not support any of insert, update and delete operations. Okay, so I just wanted to make you aware that see there is no insert, no update, no delete statement supported in Hive because internally Hive stores data in Hdfs, which is write once, read many times. So remember this, no insert, update, delete are supported. In that case, if you want to add data in Hive table, then what is the command? So there are three ways you can do it. One is load data command. We'll just use load data command to load entire data from a file. It is a batch mode. Load data in path, you give the path of the file. Okay, this is this path which you have stored in Hdfs into, let's say, table emp. So when you load this data into table emp, internally it is going to create this many classes. But once you load the data in table emp, what it does, it will actually take this file and copy it into this folder. Okay, so when you do load data command, the entire file will be moved under a directory called emp and it will be copied there, and in the meta store it will put a mapping information that this file has a data stored, this table has a data stored in this particular file in this location. Now third command is, let's say I want to select the record. I'll just say select star from employees. When I do that, select star from employee, what happens? The driver component will basically okay. So if you do select star from employee, what happens behind the scenes? The driver component of Hive will first go to the meta store, read all the metadata information about this data. It will check this file, this table will be divided into how many columns, and this table has how many, this table is divided into how many columns, and it has the file available in which location in Hdfs. So driver component will go and physically read this file from this Hdfs location and then display you the result of all the columns of this table, right? So again, internally it is going to execute everything as a map reduce to generate the data. But this is what happens when you execute any command in Hive. And this is the use of metastore as well. So is everyone clear with these components and what is the basic command that we need to use for Hive? Let me know if anybody has any question here, guys. Did we understand these three commands? Please let me know if any questions is there. So should I assume that everyone is clear? Good. So now we will do one small exercise and understand how does Hive store data into tables. Here, remember, by default the metastore is Derby, but you can configure it to use any other database to store metadata. Okay. For example, if you look at this PPT, it has mentioned that this is the metastore configuration. It has these properties needs to be set, and after that, this is the metastore configuration which will say that. Yeah, so here in this metastore file, a configuration file, you have a metastore related information defined like connection URL, connection username, password, all this stuff, right? JDBC MySQL, all the connection to the MySQL database. If you have defined all the MySQL database property, then basically it will store all the metadata into the MySQL instead of Derby database. But by default, it will use Derby database. Okay. So let us do one exercise and just quickly understand how does Hive will basically creates a table, how does it store data in table. We understood difference between Hive and RDBMS. Hive doesn't store, doesn't allow update, delete, insert commands. You have to use the load data command to load data into Hive table. So let us go to the Hive prompt and understand how do we achieve that. So I just need to type Hive. It will take me to the Hive shell. Okay. So I just type Hive on any terminal and it should take me to the Hive shell. Yeah. So now let us do one small exercise on creating a tables in Hive. So I have a let's say I have this just one second. This books file I have, which basically have two fields, user and books. So I want to basically use that. So let me create a table. First of all, let's go to the Hdfs and check under name node. We will see under user Hive warehouse directory. It would create the folder. So if you go to the utility sections, go to the Hdfs and just browse here under user Hive warehouse. I'll have some folders and database created. So I'll just say show databases. If you do that, it will show you all the databases that are already present in the Hive. Test 1, 2, 3. I'll create another database. Let's say create database test 4. Alright. And after creating database test 4, if I now do show databases, it should have one more database added as test 4. And if you go back to the Hdfs, it would create an empty directory here. Test4.db, right? It's empty. Here, if I want to create a table, I have to do this, use test4. First, I need to get into the database. If I do show tables, I don't have any tables created as of now, right? So I'll basically do this. I'll just say create table, and then I'll just say books. Table name is book, user string, book string. Okay, let's say this is the table I'm going to create. Now if I do show tables, I will have a books table listed here. And if I go to the Hdfs, I will have this books table, books directory created, which is empty because there is no data stored here, right? So if I do select star from books, it will say it doesn't have any data, right? It's empty. So here you need to basically now read the data from this table, but before that you need to load the data into this table. How do you do that? So what we are going to do is let us execute a load data command. As I said, we have a load data command through which we can load the data. So I'll just say load data local in path. See, you can load the data into Hive table two ways. One is if your file is available in the local file system, from there you can load it into the Hive table, or if your data is available in Hdfs, you can load it from there into the Hive table. Any which way is possible. So I'll just say home Cloudera Okay, this is the path of the file which I want to load it into books table. If I execute this command, it is going to load the data into the books table. Now if I do, now if I go to the Hdfs, it gives me a books file name. Got it? So when we create table, it creates a directory. When we load data into the table, it will create a file within that directory. So are we clear as of now? Any questions anybody has on this? Okay. So now we have created a table, right? And we have loaded the data. But there is a important difference between Hive and RDBMS, which I'm going to explain you here. See, Hive will follow something called schema on write. And I'm sorry, this is RDBMS. RDBMS follow the concept or the policy called schema on write. Hive will follow something called schema on read. Okay. Now what is schema on write? As you all know, in RDBMS, if you create one table, let's say employee, and that table has a column called ID, name, and salary is an integer column. Now you are trying to create or insert a record in that table with a column value as, let's say, some character instead of integer. In that case, what happens? Let's say when you are trying to insert a record in that table, which is employee table, where the column is salary, right, and which is an integer column, but you are trying to insert a character value in that integer column, then what happens? It will throw an error. It will say the validation fails, data type mismatch, or whatever, right? So basically in RDBMS tables, whenever you are trying to load any data on the table, it will always check whether the data is matching with the types of the table. Okay, if it doesn't match, it will not allow you to insert the record in that table. That is the major validation that is done by RDBMS when you are inserting record onto the table. So that is called schema on write, which means you are applying a schema definition while writing the data into the table. Okay. Now Hive will follow something called schema on read, which means when you are reading the data from the table, that time it will apply schema, not while writing. So while writing the data into table, you don't really check for any data type mismatch or any order of the columns, anything. You just load data directly into that table under Hdfs, under that directory, the file will get copied. That's it. But when you read the data from that table, let's say you do select star from that table or whatever, at that time Hive engine or driver component will basically go use the meta store to check where the file is stored in Hdfs, and then it will open that file and try to parse that file with basically proper column orders. It tries to match every column of the file with every column of the table and then give you the result. So that is why Hive is called schema on read. It tries to match the schema while reading the data, not while writing. The reason being, when you want to insert big data into Hive table, you don't really waste time on inserting it. If you want to check each and every record while inserting, it will take a lot of time. So that's why big data can be loaded in Hive table very fast because of schema on read architecture. That's the fundamental difference between both of them. Okay. Now I'll show you one demo on what do we mean by schema on read. So here I have created a table called books, and I have loaded the data from this book file into this books table. And we have already seen that in Hdfs it has created a books directory under which it has created books file. Till this point we are all good. But now what if I want to, let's say, do this, select star from books table. You can see there is something wrong here, right? User1, Hadoop is put as the value of the first column and the second column value is null. Ideally, I should have first column will be this, the second column will be this. Then why that extra null is being inserted? So you can see that this is called schema on read. See, when we have created a table in Hive, and when we wanted to load data from this file, which has two columns which are separated by comma, we did not tell Hive that the columns are separated by comma, right? And that's why Hive could not parse these two as different columns. It has taken the entire column as one column only, right? And that's why it has put entire row data as the value of the first column, which is a user column. And the second column, which is a book column, it has put null. That is why it has basically given you this kind of data, right? So while reading, the order might mismatch if you don't put the proper delimiter between the columns of the file. This is called schema on read. Okay. Did we understand this? Anybody has any question on this concept, schema on read? Okay, so nobody has a question, so let me move forward. So how do you solve this problem? So we will basically solve this problem. We'll first have to drop the table. I'll just say drop table books. Once I drop the table, after that, right, if I look at here, in the Hdfs also, the table gets dropped. Okay, and the database, the entire table itself is gone. Now I'll again create the table, but this time I'll add something. So format delimited fields. Basically, when you create a table, you need to tell that the file which you are going to load into this table as a data, that file will have columns which are separated by comma. So this statement is mandatory when you create a table. Okay. So you'll do that, and then as you can see here, two columns, whatever is a separator, you need to insert that separator. Alright. So that is something which we are putting here. And after that, you will just say load data into this table. We are fine. And if I do that select star now, I should be able to see both the columns separately. I can also see just select book from books. So it will give me only the book details. So this time it has loaded the data correctly. In Hdfs, in fact, there is no change. It will be having directory, and under that it will have file. That's it. Okay. So this is how we solve that problem of schema on read. So are we all clear with this? Any confusion on this? I haven't heard from anyone for a long time, so just wanted to check if people are following. Can I get an acknowledgement, please? So Shiva, that's what I said, right? In the previous scenario, basically null represent the second column. First column we couldn't load all the data, right? Because of the separator. No, Raj, we can't create any indexes on the Hive table. Write once, read many times. So you can't create anything. Right, Shiva? So basically it was because you did not specify the comma as a separator between columns, it could not load. See, it has actually loaded this entire row itself as a value of the first column in this table. Right, now you have loaded the first column which is username, where you both the data you loaded as a value of that column. So second column have to be put as null, right? Got it? So Olga, I have selected a query in that fashion. I have just selected second column here. Select book from books. That's why it has printed only second column, right? Otherwise, select star from books will print both the columns. Understood? No, I think, let me tell you this. So books is the name of the table. In that, book is the name of the column and user is the name of the column. Okay. So I have done this. Select book from books. Select book column from the books table. So it gives me this data. Alright. Yes. Any further questions on this? All right. So what we can do is we can take a logical pause here, right? We have to cover few more concepts in Hive, and I will cover it through practicals only. But before I start any new concept, it's already time, so I think we can take a break here. We can call it a day. We will come back in the next session, and then we'll continue further, right? So we should end the session here, and I'll cover 2 to 3 more topics are there, which I will cover it in the next session, and then we will cover scoop and flume, which are very small components. So we will understand them based on some demo, hands-on demo, and then we'll cover HBase. So that's how we'll cover the all ecosystem components. So that's all I had for today's session. We can call it a day now, and we'll meet on the Monday. Saturday, Sunday will not have a class. We'll meet on Monday and we'll continue forward. All right? Sure, Raj. I will share all the code by today. Okay? So thank you, everyone. Have a good day. Have a great weekend ahead, and we'll see you all on Monday. Thank you all.